Welcome to your first lesson in Math 1630. This is the instruction for section 1.1, and we will be discussing the slopes and the equations of lines in this section. To begin, your first question might be, why do we need to even study this? What the heck is the good of all of this? So I'm going to offer you the first example. There's a lot of everyday situations where we have two quantities that are related to each other in some way. For example, if you have a savings account or other kind of account that pays 6% simple interest per year, then the interest, which is I, capital I, that are deposited of capital P dollars, I is the interest and P is actually referred to as the principal, which is the initial investment. The amount of interest that deposit of P dollars could earn in a year is given by I equals 0.06 for the 6% times P. That equation, I equals 0.06 times P, describes the relationship between interest and the amount of money that is initially invested. So, for example, in this particular problem, if P was equal to $100, and the amount of interest earned then would be $6, and if P was equal to $200, then your interest amount would be $12. So these corresponding pairs of numbers are written as what we call ordered pairs. And those two ordered pairs, in those two ordered pairs, that order is important because the point, wrong pen. That first point, 106, indicates to us that that was the $100 that was deposited is what gained us $6 interest. And of course we saw that when we look at 212, the other ordered pair, that 212 tells us the initial deposit of $200 earned $12 in interest. And it doesn't tell us that $12 was deposited and then $200 was interest, because that would be the wrong order. So one of the things that we're going to talk about here is something called the Cartesian coordinate system. And in the Cartesian coordinate system, the horizontal number line, which in this case we're talking about this number line, that horizontal number line represents your x-axis. And that's the first components of all of the ordered pairs. And in this case, your vertical number line is referred to as your y-axis. So it's important to remember that this is your x-axis and this is your y-axis. And since your points are always written x, comma, y, then it's important to realize which one is which, because that means that your x values are going to tell you that you count from the origin x units left or right, and this is again from the origin, you'll go x units left or right. You're going to go left if your x value is negative. You're going to go right if your x value is positive. And then the second number in the ordered pair, wherever you stopped on that counting from the x, then you're going to go y units up or down. And again, up if your value is positive, down if it's negative, from where your x point landed you. So the origin that we mentioned here, the origin is at the point 0, 0. It's the point where your x and y axes intercept each other. It's called their intersection point. So just for some practice, because I'm not even assuming that you've never done this before, only that it might have been a little while since you've done this. We're going to plot some points. So the first point that we're going to plot is going to be -2, 4. And our point -2, 4 means that we're going to go on the x-axis from the origin. We're going to go -1, 2 places, and then we're going to go up 4 places, and that's going to give us this point, which is -2, 4. And we're going to find the point 0, 3 by going once again to the origin, but we're not going to go left or right because x value is 0. We're simply going to go straight up on the y-axis to the point 0, 3. So then our next point is going to be 2, -2. So once again, we're going to go back to the origin. We're going to go right 2, and then we're going to go down 2. And that's going to put us at this point right here. And then similarly, we're going to see that the point -5, 0 is here. And that the point -3, -4, we're going to count left 1, 2, 3, and down 1, 2, 3, 4. Just going to put us here at the point -3, -4. And also the point 0, 4, we're going to go once again as we did with 0, 3, and we're going to go up the y-axis to where the y value is 4. And for 1, 0, we're going to go to the right of the origin 1 unit, and we're not going to go up and down at all. We're going to stay on the x-axis just as we did for -5, but this time the x value was +1. And then our last point is the point 3, 2. And the point 3, 2, we would count right 1, 2, 3 and up 2, which would put us right here. So that's the point 3, 2. So practice plotting your points. Make sure you don't get mixed up as to which is the x direction, which is the y direction. Again, most of this should be review for you, although it may have been a while since you've done this. So next we're going to review some vocabulary and the set of points that correspond to the ordered pairs of an equation gives us what is called the graph of the equation. The x values and the y values of the points where the graph of an equation crosses the axes are called the x-intercept and the y-intercept, respectively. So on the graph that we're looking at, the x-intercept is this point right here, and the x-intercept then is at the point 8, 0. And our y-intercept then is where our graph crosses the y-axis, and that appears to be at the point 0, 6. Now we can also find intercept values from an equation algebraically. So in order to find algebraically the x and y intercepts of y equals -x plus 2, to find the x-intercept, we're going to let y be 0. So if we're going to let y be 0, I substitute the number 0 for y, and 0 equals -x plus 2. And since 0 equals -x plus 2 doesn't give me the solution yet, what I need to do is I'll need to add x to both sides, which will cancel the x's out on the right-hand side of the equal sign and leave the x on the left-hand side. And that gives me that x then would be equal to +2. And since that is an x-intercept, and it goes in the order x, y, then I know that x is equal to 2 and y was equal to 0. Similarly, for the y-intercept, we're going to let x be 0. So we take the same equation, y equals -x plus 2, and we substitute in x equals 0. So then we have y equals -0 plus 2. And actually the truth of the matter is that 0 is neither positive nor negative, so the sign really doesn't matter. And we have that y is equal to positive 2. And that gives us the point 0, positive 2. And if we wanted to graph that equation, then we could do that quite simply by setting up our x and y axis. And the point 2, 0, we would count right 1, 2. And then our y-intercept is going to be at 0, 2, so there's 1, 2, 0, 2. And then normally what we would do is we would use a straight edge, which I can't do too well on this app that I have here, but we would connect up those 2 points with a nice straight line. A little straighter than mine, hopefully. And this would give us the graph of the equation y equals negative x plus 2. So here we have the explanation of a very important characteristic of a line called the slope of a line. And this characteristic is a number that represents the slant of a line. And when we read that slant, we're always reading, remember, as we read in normal English, we're reading from left to right, which means that we're going to read the slant of the line going across the page from left to right. And what happens is this line goes down. And that tells us that actually our slope is negative, so it may slant down or it may slant upward. And here the change in the x value is actually, if you talk about the slope, we're also going to talk about the change in the x and y value. The change in the x value means that you're counting from this point to this point. And that means that you are going right, and the number of units that you travel to the right is, if you read down here to your axis, 1, 2, 3, 4. One, two, oops, 3, 4, 5. Let me count that again. So in order to count your 5 for the part that we're looking at, the reason it's 5 is because our x value is negative 3. The x value of our next point is positive 2, and that's going 1, 2, 3, 4, 5 units. So the change in x, which we refer to as delta x, is equal to 5. And then similarly, for our y change, we're going from positive 5, which is here, down to negative 4. And that's a change of 1, 2, 3, 4, 5, 6, 7, 8, 9. And since we're going top to bottom because we lead left to right and top to bottom, then that change is actually negative 9 because we went down to get that. So our change in y, which we call delta y, is equal to negative 9. So the change in the x values here was positive 5. The change in the y values was negative 9. And in mathematical symbols, we say that the change in x change in is denoted by delta, which is a little triangle. It's a Greek letter for D, delta x. And the change in the y is referred to as delta y. And that's important because that's how we actually express the formula that we're going to look at for slope, because slope, which we use M to stand for the slope, is equal to the change in y over the change in x. That's actually the way that the slope formula works. You may have memorized some y1s and y2s and things like that, but the point is that what you really need to remember is that it is the change in y, which is this quantity, divided by the change in x, which is this quantity. So here's the formula for the slope of a line. And as I said, it's delta y over delta x. And the way you find the change in the y's is you subtract the y values. And the way you find the change in the x is you subtract the x values. But you need to keep in mind that it's important that you have those x's and y's in the same order. We're going to talk a lot about that. So by this definition, the slope of the line in the previous slide would have been, remember, the change in x was positive 5, and the change in y was negative 9, and that then makes our slope negative 9 over 5. So here's an example of how you find the slope if all you're given is what the location of the 2 points are. So we have 2 points here. I'm going to call one of them the blue point. I'm going to call the other one the red point. And simply put, this is an easy way to remember how to do slope without memorizing formulas. This is kind of a visual way to learn things. The slope is going to be given by the difference in the y values, which of course is a subtraction, and that's going to be divided by the difference in the x values, which is also a subtraction. And the key here is that you want to keep your x's and your y's with their partners. So the point 76, 7 is the x value, 7 is the x value, 6 is its y value. And similarly then, the point negative 4, 5, negative 4 is the x value, and 5 is the y value. And of course, when we subtract a negative, that's going to change the way that the math actually comes out. So the slope then is equal to 6 minus 5, which is, too many ones. 6 minus 5 is 1, divided by 7 minus negative 4 is the same as 7 plus 4, which is 11. So that gives us a slope for that line between the point 76 and the other point negative 4, 5. The slope is 1 over 11. Now, I want you to keep in mind that I could just as easily have counted it the other way. I could have said that I was going to begin with the negative 4, 5. So negative 4 was the x value, and 5 was the y value. And then I could have said that I was going to, on the other end, use the point 76. So the x value is 7, and the y value is positive 6. You say, but you're going to get a different answer. Well, no, you don't, because 6 minus 5 and 5 minus 6 are the same thing. There's a difference of 1. In the last case, that difference was a negative difference. Was a positive difference. This time it's a negative difference. And negative 4 minus negative 7 is negative 11. And negative 1 over negative 11, the negatives cancels the negative, and you still come out with 11 over 1. So the key is to remember that you need to keep the coordinates of your points together over either end of your slope formula. And since you always know you're subtracting, then you really don't need to have memorized a formula at all. Just remember that the x's are on the bottom and keep your points together. Keep your coordinates together. So here's one for you to do. And what I want you to do at this point is I want you so take your time, do this problem, make sure you're doing it right, and when you unpause the video, you will see that I've given you the correct answer. So hopefully you did what you were supposed to, and you worked out the slope for the line that's going through 1, 5, and 4, 6, and the answer that you should have gotten would have been 1 over 3. So here's another example. Let's find the slope of the line through each one of these pairs of points, just for practice. So we have, again, our slope formula, which is always m, and we know it's always a fraction, which is the quotient of the differences between the y values over the x values. So beginning with my point 5, negative 3, and continuing with my point negative 2, negative 3, I see that when I have 3 minus negative 3, that's the same as 3 plus 3. Excuse me, negative 3 plus 3. And 5 minus negative 2 is the same as 5 plus 2. But because negative 3 plus 3 is 0, the fact that the change in the x's was 7 tells me that the slope here is actually 0. And that's because there was no change in the y values. And the thing that's important to realize about this is that that tells me that my line is horizontal. In other words, what's going to happen if I try to graph this is I have the point 5, negative 3, which would be here, and a point negative 2, negative 3, which might be over here. And I see that because my y values are the same for both of those, there's my negative 3 on the y-axis, then that tells me that it's a horizontal line. And a horizontal line always has a slope of 0. And that's always going to be true. Now here's another example of calculating slope. So we're going to do the same thing we did before. Slope m is equal to the difference in the y's divided by the difference in the x's. And my y values are going to be 3 and negative 4, but I'm going to remember that I'm going to go in the bottom for the x and on top for the y, and then do the same thing for the other point, in the bottom for the x and on top for the y. And that gives me then negative 4 minus 3 is negative 7. But 2 minus 2 is 0. And you're going to hear me say this a lot this semester. This is one of the 2 cardinal sins in mathematics. You cannot divide by 0. You can never do that, so you need to remember that. Because division by 0 is undefined. It is not an allowable arithmetic operation. Therefore, we say that the slope of this line is undefined. And we always use the word undefined. You may have heard that called no slope at some point in your mathematics career, but that is not an appropriate word to use. The proper word is when you have a 0 in the denominator of your slope, you say that the slope is undefined. And the reason for that is because if I try to graph the line that we're discussing here, and I try to plot these 2 points, 2, -4 means I go right 1, 2, and down 1, 2, 3, 4. And that puts me right here. And then 2, 3 says I go right 1, 2, and then I go up 1, 2, 3. And when I draw that line, I see that that line does not slant. It is straight up and down. It is a vertical line. And because it's a vertical line, we say it has undefined slope. So please keep that in mind. So you know this is important when I devote a whole slide to it. The phrase no slope should not ever be used. You need to specify whether the slope is 0 or undefined. The slope is 0 if your line is what you might want to call flat. It is undefined when it is a vertical line. This is a horizontal line. So please get those very, very straight in your head. You're going to need to remember that. Don't want it to trip you up on homework. So the thing that you need to pay the most attention to is that a vertical line has undefined slope. That's the one you got to worry about. Undefined slope. Your horizontal line, which is like your x-axis, that has a slope of 0. Everything else is somewhere in between. Slopes that go from bottom left toward top right, like those 3 lines, all have positive slope. And the ones that go from top right to bottom left Notice those all have negative slope. So now we'll continue on, talk about the equations of lines. An equation in two first-degree variables. First degree means the exponent is 1. Two first-degree variables such as 4x plus 7y equals 20 has a line as its graph, a straight line, so it is called a linear equation. So if a line has a slope of m and a y-intercept b, then what that means to us is that it passes through the point 0b and the point xy. So its slope then is 0b subtracted from xy. Now this gives us something interesting. What happens is we take this equation and we're going to simplify that equation by multiplying both sides by x. And then we're going to add b to both sides. So first I'm going to multiply both sides by x. And of course, x minus 0 is just x. So I'm going to multiply both sides by that x. And what happens then is that these x's cancel. And I'm left with mx equals y minus b. So then if I add b to both sides, what I actually get is that y is equal to mx plus b. And we call this the slope-intercept form of the equation of a line, slope-intercept. That's a very important and very useful form to have. There's several forms, but that's the one that we use with the graphing calculator. So the slope-intercept form is also often referred to as the function form of a line. In other words, and instead of having y equals mx plus b, sometimes what we'll see instead is f of x is equal to mx plus b. And this is called function notation. It doesn't mean f times x. It means that y is a function of x, or f of x function of x. So we're going to use what we've learned to write some equations. The first one we're going to write is, it says find an equation in the slope-intercept form, which means we need y equals mx plus b, for a line that goes through 0, negative 3, and which has a slope of 3/4. And what that slope of 3/4 tells us is that that's the value of m. And what that 0, negative 3 tells us, this is a y-intercept. And that tells us then that b is equal to negative 3. That's going to be where it crosses the y-axis. So when we do the slope-intercept form, we have y equals the slope 3/4 times x plus the value of b, which is -3. And that gives us the equation with all the simplification done of y equals 3/4 x minus 3. And that is your equation in slope-intercept form. Example 2 is similar, except what we're given here is we're given an x-intercept and a y-intercept. The x-intercept says an x value of 7 and a y value of 0. The y-intercept has an x value of 0 and a y value of 2. And we'll just do our slope formula to find a slope. So that gives us -2 over 7 is our slope. Then we know that we have y equals mx plus b. And what we've just learned is that m is -2 over 7. What we don't know is the value of b, or do we? Since b is the y value of the y-intercept, then that tells us that b must be 2. So therefore, our equation in slope-intercept form is y equals -2 over 7 times x plus 2. So here's another one for you to do. Pause your video at this point, and you find the equation of a line that has an x-intercept of -4 and a y-intercept of 6. Okay, hopefully you got this one right. Your equation should be y equals 3 over 2 times x plus 6. If you didn't get that and you can't find your mistake, be sure and ask in class. Okay, so here we have another example. Example 3 says we're to find the slope. So we're going to focus on finding the slope. And this time we have an equation, 3x minus 4y equals 12, and that equation is in what we call standard form. Which simply means that the form of the equation is a times x plus b times y is equal to c, and a, b, and c are just numbers. It's the coefficient of the x and y terms and the value of the constant on the right-hand side of the equal sign. And since all we really want to do is find the slope of that line, what we could do is take that equation in the form that it's in and change it into slope-intercept form. Which is y equals the slope times x plus b. And we don't actually even have to find the whole equation, we just really need to find the slope. So what we would do is we'll take the original equation that we have here, 3x minus 4y equals 12. We're going to subtract 3x from both sides, which of course will have the effect of eliminating the x's on the left-hand side. And then what we have left is negative 4y equals negative 3x plus 12. And since we're looking to have this solved for y, we'll divide every term in the entire equation by the -4, which gets rid of the -4 in front of the y and leaves us with y equals negative 3 over negative 4 is positive 3/4 x, and 12 divided by negative 4 is negative 3, so when we add a negative 3, we have that we're going to subtract a 3. And the key here then is that we have the correct slope, which is 3/4. So, that's one way to do it. There is also a second way to do it. The second way to do it would be to find the x and y intercepts. Which means we're going to let y be 0 for the x-intercept, and then we're going to find the y-intercept, which means we're going to let x equal 0. So beginning with 3x minus 4y equals 12, and y is equal to 0 means I wind up with 3x minus 4 times 0 is 0, is equal to 12. And that gives me then that x is equal to 4. So that's the point 4, 0. Similarly with the y-intercept, we're going to let x be 0. So that means we have 3 times 0 is 0 minus 4y equals 12. And dividing both sides by negative 4 gives us that y is equal to negative 3. And that gives us the point 0, negative 3. And then we can simply use our slope formula so we have 0, negative 3, and 4, 0, and negative 3 minus 0 is negative 3, and 0 minus 4 is negative 4, and negative 3 over negative 4 is 3 over 4. So you could do that either one of those two methods. There's actually two really good methods to use to answer example 3. Here again, you have another one for you to do. So please identify the slope of this line. So hopefully now that you've unpaused it and you look at the answer, you'll see that your work supports that the slope is negative 8 over 3. And again, if you didn't get it right, please go back and try to find your mistake. If you can't find your mistake, then be prepared to ask in class and I'll be glad to help you with it. Our fourth example says to find the equation of the line that passes through the point 3, negative 7 and has a slope of 5 over 4. Now, there is a formula in your textbook, and you may have seen this formula before in other classes. It's called the point slope form. And you can use the point slope form, but since I don't believe in knowing 15 different ways to do the same simple thing, and I just as soon hold it down to as many formulas or as few formulas as we can, then I'm going to tell you that you really can just go straight back to your slope-intercept form. Which is y equals mx plus b, because you're given the slope. And the other thing that you're given is you're given a value of x and y. So the only thing you don't know is b. The simplest way to do this then is to say that y, which is negative 7, is equal to the slope, which is 5 over 4, times x. Oh, and by the way, x is positive 3. plus b, and b is the only variable here. So the first thing we'll do is we'll multiply. You can approach this again 2 different ways. You could multiply through the whole equation by 4 just to get rid of the fraction, but in this case it's actually just as simple to say that 5 times 3, remembering that 3 is over a 1, 5 times 3 gives us 15, over 4 times 1 is 4, plus b is equal to -7. And then we're going to subtract 15 over 4 from both sides. So we're going to wind up with nothing but b left on the right side. And then b, for that reason then, is equal to -7 over 1 minus 15 over 4. Now, your calculator can help you with this arithmetic, and if you don't know how to do that, you need to be singing out and letting me show you, or to talk with one of your neighbors, because I'm sure there's lots of folks that do know how to do this problem simply using your calculator to subtract those 2 fractions. I'm going to do it by hand just so that you remember that it is possible to do this arithmetic, but I'm not telling you you can't use your calculator. B is going to be equal, since we need a common denominator, and that common denominator is 4, then -7 over 1 becomes -28 over 4 minus 15 over 4. And -28 minus 15 is -43 over 4. And you don't have to put that in anything simpler than that. You don't have to make it into a mixed number. Leaving it as -43 over 4 is just fine. So the equation then that we're looking for is y equals 5 over 4 times x plus our y-intercept, -43 over 4. Or y equals 5/4 times x minus 43 over 4. And you don't have to go any further than that, except I'm please asking you now, probably most of the time you don't want to change that into a decimal unless you're actually trying to plot the point on a graph grid. So in this case, it would be acceptable to say that that's -10 3/4, which is -10.75. So that is an acceptable answer. Point slope form with 2 points is done exactly the same way. Even though you could use what's called the point slope formula, you do not have to. We can again go to y equals mx plus b. Because even if you use point slope form, you'd still have to use these 2 points to calculate the slope. So our first point is 5/4. Our second point is -10, -2. So then that tells me that my slope, 5 minus -2 is 5 plus 2, or excuse me, 4 minus -2, which is 4 plus 2 is 6. And 5 minus -10 is 5 plus 10, which is 15. And because I can divide both of those by 3, 3 goes into 6 2 times, 3 goes into 15 5 times, then my slope for this equation is 2/5, 2 over 5. And now I can choose either point to be my xy. And I'm just arbitrarily picking the one that has single digits because the math is easier. So I'm going to go back with y equals mx plus b. My slope is 2/5. And I'm going to replace my xy with x is equal to 5 and y is equal to 4. So then I have 4 equals 2 times 5 is 10, and 5 times 1 is 5, plus b, and 10 over 5 is 2, so I will subtract 2 from both sides. And 4 minus 2 is 2 is equal to b. So I have everything I need to know. The value of b is 2, the value of the slope is 2 over 5, and my answer then is that y is equal to 2 over 5 times x plus the value of b, which is 2. And again, here I want you to pause the recording and try to work this one out and make sure that you get the answer that I'm going to show you when you unpause it. So here we have the equation that connects the 2 points, 2, 9 and 5, 3. And our equation is y equals negative 2x plus 13. Example 6 is an example of a horizontal line. If you weren't told that it's a horizontal line, what you should recognize very quickly is that your y values here are both negative 4, regardless of what x was. So what that's going to cause to happen is you're going to find out that the slope in this case is going to be equal to 0 because we have 8, negative 4, and negative 2, negative 4. And when we do the subtraction, it doesn't matter that 8 plus 2 is 10, negative 4 plus 4 is equal to 0, so that tells you that your slope is 0. And the only thing you don't know is what is the y-intercept, but guess what? If the slope is 0, the y-intercept is going to be the only y value you've got. So y equals the slope, m times x plus b, will tell you that if you pick either one of the points to put in for xy, for example, if x is 8 and y is negative 4, and I put in my slope of 0, I'm going to see that b is equal to negative 4, as I said it would be, and therefore the actual equation then is going to be y equals 0 slope plus negative 4, but since 0 times x is just 0, then it turns out that y is equal to negative 4, which is, as it says, a horizontal line passing through all of the y equals negative 4 values. And just to further the example here, plotting 2 points given, which was the 2, negative 4, and the 8, negative 4, you see that you do indeed get a horizontal line through the point, all the points on y equals negative 4. every horizontal line has a slope of 0. And therefore, the form of its equation is always y equals k. And k is the y value of all of the ordered pairs. Okay, so this time what we have is we have a vertical line. And when we try to calculate the slope, we've already been over this once, but this is just a reminder. This should tell you this is very important. When you calculate the slope, the point 4, 3, and the point 4, -6 will indeed give you 3 minus -6 is 3 plus 6, which is 9 in the numerator, but 4 minus 4 is 0 in the denominator, which means your slope is undefined. And anytime you have an undefined slope, that tells you it is a vertical line, which tells you because it's a vertical line, that what happens when we plot 4, 3, 1, 2, 3, 4, 1, 2, 3, and 4, -6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and we connect those 2 points, that is indeed a vertical line, and they all have the x value of 4. So therefore, our equation of our line is x equals 4. Anytime you have undefined slope, your equation is going to look like that. So again, plotting those ordered pairs, 4, 3, 4, -6, gives us the line that is shown here on this graph, and that line is x equals 4. So the straight line shows the equation x equals 4 represents a vertical line. And every vertical line has an undefined slope. So the equation is always of the form x equals some number k, where k is the x value of all of the ordered pairs. Now, since I know that it is entirely possible that you will get confused, I'm going to give you a little way to help you remember this. Horizontal lines are flat. That means their slope is equal to 0. And that's because they go back and forth. They're flat. Vertical lines, on the other hand, are up and down. And their slope undefined. Okay? Just remember H for horizontal, straight back and forth across, V for vertical, up and down. So in summary, this is what we've learned. We've learned the slope of horizontal and vertical lines. The slope of a horizontal line is 0. The slope of a vertical line is undefined. We've learned to use the standard form, the slope-intercept form of an equation where the slope has the value of m and the y-intercept is b. We've learned that a vertical line always looks like x equals some number k, and it has no y-intercept except wherever k is equal to 0. And we also have horizontal lines, which is y equals k. And there is no x-intercept, except, of course, where k is equal to 0. And their slope is 0, whereas vertical lines had undefined slope. You need to not just memorize, but you need to kind of internalize this last summary page, because that's going to be used over and over and over for the next year in your mathematics course. So this concludes most of our examples here. We are going to proceed onward. I have a few more things to tell you, and then there's going to be some parts that I'm going to refer to in class. So the remaining examples that are on this handout will be demonstrated in class, so that I can be certain that you're able to use your TI 83 or 84 calculator in this course. Be sure and bring that calculator with you. I am not going to complete this recording with those few problems. I'm actually going to do those in class on Tuesday. So wrap up your notes, post your notes, and I'll see you on Tuesday.